In this video we're going to be looking at how you must choose the correct model for a continuous uniform distribution. We'll be doing that with this first exam question here, and then we're going to look at a second exam question where the continuous uniform distribution is applied to another type of probability distribution. And that's quite a popular exam type question that has been coming up in the recent years. But let's look at this first one here. So we're covering this first point, choosing the correct model. The question asks, a string AB of length 5 centimeters is cut in a random place C into two pieces. The random variable x is the length of AC. We're asked to write down the name of the probability distribution of x and sketch the graph of its probability density function. A bit of a giveaway in this question is that we're asked to sketch the graph of its probability density function. So we know that it's a continuous random variable because it's got a probability density function. And, well, the information here tells us that the string is cut in a random place. So it could be cut anywhere along those 5 centimeters. So we know that this is continuous uniform distribution. So that would gain us 1 mark of the 3 in part A. We're also asked to sketch the graph. So if we sketch in our graph, we know it's between 0 and 5, and it's a straight line and 0 otherwise, and the height of that graph there is going to be a fifth. So the marks on offer here was, well, you'd get 1 for having all of these 3 correct labels and another 1 for having these 3 correct straight lines. So this is the PDF and this is showing that it's 0 otherwise. So you can see it's fairly simple to recognise these types of questions. I'm going to finish it off. It's not a difficult question. Part B, we're asked to find the mean and the variance. So for the mean, we know that the formula is A plus B over 2. In this case that's 0 plus 5 over 2, so that's 5 over 2. So the expectation of x here is 2.5. For the variance of x, we know that the formula is b minus a squared over 12. So b minus a is 5 squared, that's 25 over 12. I could leave my answer like that, or I could write it as a decimal, which is going to be 2.083 recurring. Last couple of questions here, both only worth 1 mark. Part C, we're asked to find the probability that x is greater than 3. So on our graph we can show that. So there's 3, we want the area where it's greater than 3. So that's going to be 2 times a fifth, so that's the width of the rectangle multiplied by the height, which will give us that area, which is of course 2/5. And then finally we're asked to find the probability that x is equal to 3. Now because this is a continuous random variable, the probability of it being one exact value is 0. Okay, so now let's move on to the second type of question that I want to cover, and that's where we are applying the distribution, the continuous uniform distribution, to other types of distribution that come up in this statistics module. So let's get straight into the question. a manufacturer produces sweets of length L millimeters, where L has a continuous uniform distribution with range 15 to 30. So I'm going to write down that information that we've been given. So L has a uniform distribution 15 to 30, and we're asked to find the probability that the randomly selected sweet has a length greater than 24 millimeters. So we're asked to find the probability that L is greater than 24. So for this question, I'm going to draw a graph, and it's between 15 and 30. The height in this case is going to be 1 over 15, and we're asked to find the probability that L is greater than 24. So mark in 24 on our graph. We need to find that area there. So this length here is 6, the height is 1 over 15, so we need to multiply 6 by 1 over 15, which will give us an answer of 2 over 5 when we simplify our fraction. Okay, so now we're told that these sweets are randomly packed in bags of 20 sweets. Find the probability that a randomly selected bag will contain at least 8 sweets with length greater than 24 millimeters. So here the distribution is changing. We know that the probability of getting a sweet which has a length of 24 or more is 2 over 5. All of these sweets are packed into bags of 20, and we need to find the probability that one bag will contain at least 8 sweets with length greater than 24 millimeters. So what I can see is that we've got a sample of 20 sweets, and we need to find the probability that 8 or more would be greater than 24 millimeters. So in this case, it looks like it's going to be a binomial. So I'm going to define x as the number of sweets with a length greater than 24. So number of sweets with a length greater than 24. And x has a binomial distribution of 20, and the probability is 2 over 5, which is 0.4. We're asked to find the probability that x has at least 8 sweets. So x is greater than or equal to 8, which is the same as 1 minus the probability that x is less than or equal to 7. Conveniently, 0.4 is in our tables, so we can just use the tables for this one. Sometimes you get a probability that's not in the tables and you'll have to use the formula. But in this example we can use the tables, so looking that up in the tables we'll get 1 minus 0.4159, 0.4159, which is 0.5841. And then finally, for part C, we're asked to find the probability that 2 randomly selected bags will both contain at least 8 sweets with length greater than 24 millimeters. So in this case, both have a probability of 0.5841, so we're just multiplying those two probabilities together, and that gives us 0.341.